how can we model two individuals in a way that they want to coordinate or not? And so this is what we're going to do in this motivating example. And so what we're going to assume is that we have Alice, and Alice really likes sports movies. So Alice really likes sports movies. And then we also have a Bob. Oops, let me be consistent with my coloring here. We also have another person, Bob, and Bob really likes comedy. And so Alice and Bob need to choose which movie they're going to see, either sports or comedy. And if we imagine that they are not coordinating, so they're not talking to each other and talking it out, and Alice is convincing Bob to go see sports, or Bob is convincing Alice to go see comedy, where will they end up? What will they end up doing? And how can we model this? An important thing I haven't said yet is that Alice and Bob really want to go to the movies together. So while Alice prefers to see a sports movie and Bob prefers to see a comedy, what they really care about is going together. So in this situation where Alice will choose either sports or comedy and Bob will choose either sports or comedy, we have four scenarios that can occur. Scenario one is that Alice goes to see sports and Bob goes to see sports. Scenario two is that Alice goes to see sports and Bob goes to see comedy. Scenario three is that Alice goes to see comedy, Bob goes to see sports. And scenario four is Alice goes to see comedy and Bob goes to see comedy. The ordering there is irrelevant. I'm kind of just coming up with some sort of logical ordering. But these are our four scenarios. And the scenarios that are nice ones are that Alice and Bob go to both to see sports, or Alice and Bob go to both see comedy, because they both then are enjoying the same movie together. But Alice would prefer scenario one, because they're both going together and Alice seeing the movie that they want. And here, this is the scenario that Bob would prefer. So the way we're going to represent this is according to the two dimensions that correspond to the choices of Alice and Bob. So we're going to say that Alice can choose the vertical dimension. So we've got sport or comedy. And then we've got Bob can choose, again, sport or comedy. And so those four scenarios just map naturally to here. This is scenario one, this is scenario two, three, and four. And those are just the same scenarios here. Okay. And so once we've got this two-dimensional kind of representation of the possible outcomes, we want something now to denote how good each outcome is. And by what we mean by how good, we actually don't mean how good overall, but we mean how good in a quantifiable way it is to each individual. And so there we're going to talk about something called utility. And so utility is going to be an important, well, my T is not terrible there, is it? Utility is going to be an important word, and utility is going to be a numeric representation of the outcome, okay? So let me just move this over ever so slightly like that. And the way we're going to do this, because we're going to take into account the utilities of both people, of both individuals as individuals, we need two ways of doing this. And so in fact, what we're going to do is we're going to use matrices, and we're going to have a matrix A to represent Alice's utilities and a matrix B to represent Bob's utilities. And now we're just going to map the scenarios to numeric values. And so in scenario one, we're going to say that Alice gets a utility of 3 and Bob gets a utility of 2. In scenario 2, we're going to say that Alice gets a utility of 1 and Bob gets a utility of 1. In scenario 3, a utility of 0 and a utility of 0. And scenario 4, we're going to have a utility of 2 and a utility of 3. Now, these numeric values are very much just picked out of the air, but what's important is that they correspond to the situation I've described. And more importantly than that, they correspond to ordered preferences for the individuals. And so to just go over that a little bit more, in scenario one that we had here, we said that Alice would prefer this out of all the outcomes, and indeed, their utility is 3. Because they get to not only go to see a movie with Bob, they also get to see a movie of their choice. And so whilst Alice gets a utility of 3, Bob gets a utility of 2. And that's because 2 is the benefit Bob gets from an outing with Alice, but that 2 is not the best possible scenario for Bob, which is this 3 down here, which corresponds to scenario 4. The 1s, they correspond to scenarios 2 to scenario 2, which is when they both go see a movie by themselves, but it's the movie of their choice. And then finally, the 0 is when they went to see a movie by themselves, but it's the movie of the other person's choice. And this object here, this pair of matrices, is called a normal form game. And we're going to talk about that shortly. And it's the start of modeling the situation mathematically that we're now going to be able to do to kind of get some insights into the actual outcomes of behaviors.